Let's look at the next question here. If the quadratic equation ax squared plus 2cx plus b equal to 0 and ax squared plus 2bx plus c equal to 0, where b and c are unequal, have a common root, then what is the value of a plus 4b plus 4c? The options are 0, minus half, 2 and 1. Let's look at the problem here. Ax squared plus 2cx plus b equal to 0 is the first equation. Second equation is ax squared plus 2bx plus c equal to 0. Now suppose x is a common root for them, that is satisfying both the equations. Let us subtract one from the other. So what is it you get? Subtracting, we get 2 into c minus b into x plus b minus c is equal to 0. So from here we can say this is c minus b into 2x minus 1 equal to 0. Taking c minus b common here. Since c minus b is not equal to 0, x has to be half. Now this half is a root common to both of the equations. So that means half should satisfy this equation. So a into half square plus 2c into half plus b is equal to 0. So this 2 cancels and you have here a by 4 plus c plus b is equal to 0. That gives me a plus 4b plus 4c to be equal to 0. So the right option is answer A. Let's move to the next question here. If the equation ax squared plus bx plus c equal to 0 and x squared plus 2x plus 3 equal to 0 have a common root, then a is to b is to c is 1 is to 2 is to 3, b 3 is to 2 is to 1, c 4 is to 9 is to 16, d none of these. Now let's look at the second equation. X squared plus 2x plus 3 equal to 0. The discriminant of this is 4 minus 12, that's negative. B squared minus 4 is c, that's negative. So this has no real roots. It has imaginary roots. Now ax squared plus bx plus c equal to 0 and this should have a common root. But suppose alpha plus imaginary root, say alpha plus I beta and alpha minus I beta. If alpha plus I beta is a common root of these two, complex roots occur always in conjugate pairs, so alpha minus I beta will also come out to be the common root. So which means that the coefficient, both the roots should be common. So the coefficients, what is the condition for both the roots to be common? The coefficients of the like coefficients should be proportional. So what is it? You can say a by 1 should be equal to b by 2 and c by 3. So a is to b is to c is therefore 1 is to 2 is to 3. So the answer is 1. First option, answer A. Let's look at the next question here. The equation ax squared plus bx plus c equal to 0, x cubed minus 2x squared plus 2x minus 1 equal to 0 have two roots in common. Then what should be the value of a plus b? A plus b is equal to a 1, b minus 1, c 0, d none of these. Now let's have a look at these equations. Ax squared plus bx plus c equal to 0. Let alpha and beta be the roots of this equation. Roots. Alpha plus beta will be minus b by a and alpha into beta will be equal to a by a, that is 1. Now let the roots of the second equation, that is cubic polynomial equation, x cube minus 2x square plus 2x minus 1 equal to 0 be alpha beta. He says there are two roots common, so these two, let us say, assume they are the common roots. So both the roots alpha beta and some other root gamma, that's the extra root. We know that whenever you have a cubic polynomial equation like this, sum of the roots is given by minus of the coefficient of x square by coefficient of x cube. So alpha plus beta plus gamma is equal to minus of minus 2 by 1. That is 2. Now this is S1 we call. S2, sum of the roots taken 2 at a time. That's given by alpha beta plus beta gamma plus gamma alpha. And what is that equal to? Coefficient of x by coefficient of x cube. So what do we have here? 2 by 1. That's 2. Now S3, alpha into beta into gamma, that is sum of the roots taken all the 3 at a time. So there's only one possible combination here, alpha into beta into gamma. Here alpha into beta into gamma should be equal to constant term with a minus sign. So minus of minus 1 by the coefficient of x cube, that's 1. So that makes it 1 there. Here, let us note a key point that we are using. That is, whenever you have an equation, polynomial equation a naught x power n plus a1 into x power n minus 1 plus a2 into x power n minus 2, so on, an equals to 0. The sum of the roots taken 1 at a time. So alpha 1, alpha 2, alpha n are the roots. Sum of the roots taken 1 at a time is given by minus a1 by a naught. S2, that is sigma alpha 1, alpha 2. All possible combinations, alpha 1, alpha 2, alpha 1, alpha 3, all possible combinations, NC2 combinations of sums we'll have here. When you add them up, you'll get a2 by a naught. So there's an alternating sign pattern here. S3 will be sum of the roots taken 3 at a time, alpha 1 into alpha 2 into alpha 3. You'll have NC3 combinations here, and that's given by minus a3 by a naught. So finally, that is S3. Go on like that. Sn will mean sum of the roots taken all the time at a time. All products of sum of products of roots all taken all at a time. So alpha 1 into alpha n. What is that equal to? Minus 1 power n into an by a naught. So that is, when you have S1, you have a minus 1 power 1, S2 minus 1 power 2, S3 minus 1 power 3. So Sn should have minus 1 power n into an by a naught. So we made use of this formula here, and we observed that alpha into beta was already 1 there. So now alpha into beta into gamma is also 1. Therefore, from this equation 1 and 2, we have from 1 and 2, we have gamma to be equal to 1. Now, alpha plus beta plus gamma is equal to 2, we know from here. Gamma is already found to be 1, so alpha plus beta must be equal to 1. That gives me minus b by a to be equal to 1. So which gives me a plus b to be equal to 0. So the value for a plus b is 0. So answer for this question will mean C. Now the common roots of the equation x cube plus 2x square plus 2x plus 1 equal to 0 and 1 plus x power 130 plus x power 1988 equal to 0 are a omega, b omega square, c minus 1, d omega and omega square. Now let us understand what is this omega and omega square. Omega and omega square are cube roots of unity here. That is, the equation x cube minus 1 equal to 0, if you consider, it has two factors, x minus 1 into a quadratic factor x square plus x plus 1 equal to 0. So x equal to 1 is a root. The roots of this are denoted by omega and omega square. This gives rise to roots omega and omega square. Clearly, 1 plus omega square, what is the coefficient of x squared here? It's a 0. So sum of the roots will be 0. And what is the product of the roots? 1 into omega square is minus of minus 1, that is equal to 1 there. Okay, even the otherwise also, omega is a root of this, so omega cube has to be 1. Okay, so these are the two relations that we have here for omega and omega square. Now let's see if that omega and omega square satisfy this one, which of them will satisfy this equation. One more thing that I should say here, if omega satisfies one of the equations, it has to satisfy, omega square also should satisfy, because they are actually complex conjugates of each other. So for a polynomial with real coefficients, whenever imaginary roots occur, they occur in conjugate pairs. So whenever omega is a root, if I check that omega is a root common to both of them, omega square also has to become a root for both the equations, common root for both the equations. So the most plausible answer, if at all, you can't have A, you can't have B, you can maybe have C, but if at all, you should have D. So let's check for omega. Omega cube, let me plug in that value omega here. Omega cube plus 2 omega square plus 2 omega plus 1. Here omega cube is 1. Okay, 2 into omega square plus omega, what is omega plus omega square? Minus 1. So 2 into minus 1 plus 1, that's clearly 0. So omega is a root for the first equation. Now check that, it's easy to check that it's a root for the second equation as well. 1 plus omega power 130 plus omega power 1988. Okay, you can observe that this will turn out to be in the form of 1 plus omega square, because omega power, this will come, one of them will come out to be in the form of omega power 3q plus 1, and other one will turn out to be in the form of 3q plus 2. So this will come out to be omega square, and this will come out to be omega. So 1 plus omega square, and that's equal to 0. Omega to be common root for both the equations. But whenever you have roots, I said imaginary roots occur in conjugate pairs for a polynomial with real coefficients. So if omega is a root for the first equation and second equation, omega square also must be the root for both the equations here. So the right answer is D. Answer is D. Okay, let's move to the next question here. If ax square plus bx plus c equal to 0 and bx square plus cx plus a equal to 0, where a not equal to 0 and b is not equal to 0 have a common root, then the value of a cube plus b cube plus c cube minus 3abc is equal to what? That is, first option 0, second option 1, third option 2, and fourth none of these. Let's see, what is the condition for common roots? I have two equations, ax square plus bx plus c equal to 0 and bx square plus cx plus a equal to 0 here. These are the two quadratic equations. Suppose alpha is a common root. Common root. So we have a alpha square plus b alpha plus c equal to 0 and b alpha square plus c alpha plus a is equal to 0. We'll use the cross ratio formula here, alpha square upon ab minus c square is equal to alpha upon, alpha is the common root of the equations, means a alpha square plus b alpha plus c is equal to 0, b alpha plus c alpha plus a is equal to 0. Now using the cross ratio formula, alpha square into alpha square divided by a into b minus c square, alpha divided by b into c minus a square, 1 upon, now in the ac minus a into c minus b square. So the square of this must be equal to product of these two. So bc minus a square, the whole square, must be equal to ab minus c square into ac minus b square. Opening it up, we have a square, b square c square plus a power 4 minus 2a square bc, and here we have a square bc, ab into ac minus AB cube minus AC cube plus B square C square. Now this B square C square and this B square C square, we can cancel it out. So let us cancel out this B square C square both sides, and we find that in fact we have A common in entire on both sides here, A cube minus 2ABC, and here another ABC will make it minus B 3ABC. If you pull both the terms this side, you get B cube plus C cube, and that is equal to 0. So we get then A cube plus B cube plus C cube minus 3ABC equals to 0. So answer for this is A. Okay, let's look at the next question. ABC are real, C negative, and ax square plus bx plus c equal to 0 has no real roots. Then A plus B plus C, the sign pattern of A plus B plus C is asked. A plus B plus C should be positive, or A plus B plus C should be negative. 0 should lie between minus 1 and 1. Let's have a look at this. Now ABC are real, and we are given this quadratic expression ax square plus bx plus c. Let's call this as f of x. He says that f of x equal to 0 has no real roots. That means when I draw the graph of y equal to f of x, that is y equal to ax square plus bx plus c graph, has to be completely above the x-axis like this, or it should be completely below the x-axis. Now what should have been the is the graph like this or like this? So let us use some other information here. F at 0 here, if it is like this, that means for every x f of x is positive. For every x f of x is positive for all x. Here f of x is negative for all x. How is the graph? He has given that c is negative. But what is c? C is nothing but f at 0. F at 0 is c. So f at 0 is negative. But only at one point you can't have negative value. It has to be negative for all x. So f of x should be negative. So the graph must have been this. Graph of this y equal to f of x must have been like this. That is, this is the x-axis. Therefore, for all x, the y coordinate is negative. That is, it's totally below the x-axis. So which means that f at 0 was negative, f at 1, f at 2, f at 3, at every point it should be negative. So what we have here is, we are asked to find out the value of a plus b plus c. What is a plus b plus c? Can you guess? It has to be f at 1. See, when I put x equal to 1 here, I get a plus b plus c. That is f at 1. Now what do you know about f at 0? F at 0 was negative. F at 1 also should be negative. So what should happen then? This should also be negative. So what we can conclude is a plus b plus c is negative there. So the right option is B. Answer is B. Now if I had asked if the question were to be framed like this, that is, he has asked, suppose 4a plus 2b plus c. What is the sign pattern of this? Now what would have been this value? It would have been f of 2. See, a into 2 square plus b into 2 plus c. That would have also been negative. So you can frame many such questions there. So clearly it's based on the graph there. So we have to look at this graph. Right. Let's look at the next question here. If lambda square plus lambda minus 2 into x square plus lambda plus 2 into x is less than 1 for all x real numbers, then lambda belongs to what interval? A minus 2 comma 1 open interval, B minus 2 comma 2 by 5, C 2 by 5 comma 1 open interval, and D none of these. Let's have a look at this equation. In equation here, lambda square plus lambda minus 2 into x square plus lambda plus 2 into x. I rewrite this inequality like this. So remember that whenever you are given a quadratic inequality, you must always bring it into the form of one of the sides being 0. Inequality should have one of the sides as 0. Now this quadratic inequality, lambda square plus lambda minus 2 into x square plus lambda plus 2 into x minus 1, I want it to be negative for all x. That means when I draw the graph of this y equal to this ax square plus bx plus c kind of quadratic curve, I want it to be totally negative. We know it's going to be a parabola shape. I want it to be negative. When is this going to happen? The shape of the graph will be like this whenever the coefficient of x square is negative. So coefficient of x square must be negative and discriminant should be negative. So what are the values of lambda when both these criteria are going to be held? Common values of lambda for which both these criteria are satisfied. Coefficient of x square less than 0. What does it mean? Lambda square plus lambda minus 2 should be less than 0. That gives me lambda plus 2 into lambda minus 1 should be less than 0, factorizing. Now therefore lambda should lie between minus 2 and 1. This is what we can say. Lambda should belong to the interval minus 2 to 1 there. That is from the coefficient of x square being negative. Now what about the discriminant? Discriminant also has to be negative. So what is it? You can say lambda plus 2 the whole square, discriminant b square minus 4ac, lambda plus 2 the whole square minus 4 into lambda square plus lambda minus 2 into minus 1 should be less than 0. So this minus 1 and this minus 1 will make it plus there, and we can write here we have a lambda plus 2 common here because this has been already factored as lambda plus 2 into lambda minus 1. So we have here, I'll take out lambda plus 2 common there, and then we have lambda plus 2 plus 4 into lambda minus 1 to be less than 0. So that gives me lambda plus 2 into, what about this? 4 lambda plus lambda 5 lambda and minus 2 there. That should be less than 0. Okay, from here we observe that when is this going to happen? When lambda lies between minus 2 and 2 by 5. We observe that here for the first criterion gives us lambda should belong to minus 2 comma 1 open interval. Here on the other hand, when I look at the discriminant less than 0, I am getting the condition that lambda should belong to this. So what is the common region? Lambda should belong to minus 2 to 2 by 5. 1 is here. But the common region is this portion. So lambda therefore must belong to minus 2 comma 2 by 5. Therefore the answer is B. Let's move to the next question. If the expression mx minus 1 plus 1 by x is always non-negative for positive mx, then the minimum value of m must be a minus half, b 0, c 1 by 4, d 1 by 2. So let us look at this expression here. Mx minus 1 plus 1 by x is non-negative. Now let us rewrite this as a quadratic expression. Mx square, taking the LCM, minus x plus 1 by x should be non-negative. I want this to happen for all x positive. Okay, for all x positive we want this to happen. Here x being positive, I'll ignore this part. So we want this mx square minus x plus 1 to be non-negative for all x now, for all x positive. Okay, now we will look at this. M is also positive here. M is positive quantity. So if you want this to be non-negative for all x positive, so what is it you must have here? So the graph should be either above the x-axis or touching the x-axis here. It can be like this. Okay. Now I want the discriminant to be therefore less than or equal to 0. Discriminant should be less than or equal to 0. What is the discriminant here? 1 square minus 4 into m. That should be less than or equal to 0. From here, 4m should be greater than or equal to 1. This implies m should be greater than or equal to 1 by 4. So the least value of m that we observe is 1 by 4 there. So minimum value of m should be 1 by 4. Here let's look at this, go through this one. Again, we have a quadratic expression that has to be non-negative for all x. M is given to be positive. So we want this inequality to happen. I've ignored x because since x is positive. By multiplying by a positive quantity, inequality is not reversed. So we have like this. So the graph could be either this or this. So when will this kind of thing happen? Because m is positive, concave upwards, the graph should be, and the discriminant should be less than or equal to 0. So b square minus 4ac, 1 square minus 4m should be less than or equal to 0. From there I get m to be greater than or equal to 1 by 4. So the answer is C. Now let's next question here. The least value of the rational function x plus 2 by 2x square plus 3x plus 6 is a minus 1 by 13, b 1 by 13, c 1 by 3 and d minus 1 by 3. So how do we go about doing this problem? Now what I do is I take this as y, the expression as y equal to x plus 2 by 2x square plus 3x plus 6. Now this is a real valued function. It's like finding out the range of this, the least value for this function. We have the calculus method, but let's go by a simple algebraic process. Now let's cross multiply. We have here 2y into x square plus 3y into x plus 6y is equal to x plus 2. Let's rewrite this as a quadratic equation in x. So 2y into x square plus 3y minus 1 into x plus 6y minus 2 is equal to 0. Now this x has to be real. Now the question is, for what values of y is now treated as a coefficient. For what values of y is this going to have real roots? So we will find out that by equating the, having the discriminant to be non-negative. So discriminant non-negative is the criterion for a quadratic equation to have real roots here. Okay, so 3y minus 1 the whole square minus 4 into 2y into, we can take out a 2 common from here as well. We'll write it as 3y minus 1 greater than or equal to 0. The discriminant of this quadratic expression has to be non-negative. So for that, let's look at this. We have 3y minus 1 the whole square minus 16y into 3y minus 1 greater than or equal to 0. So 3y minus 1 can be taken common here, and we have 3y minus 1 into minus 16y greater than or equal to 0. So that gives me 3y minus 1 into, what about this? That makes it minus 13y plus 1 greater than or equal to 0. Minus of 13y plus 1 greater than or equal to 0. So that gives me 3y minus 1 into 13y plus 1 less than or equal to 0. I am multiplying by minus sign. Y should lie between minus 1 by 13 and 1 by 3. So This is the range of y. The least value of y is minus 1 by 13. Least value or minimum value of the expression y is minus 1 by 13. Had we been asked the maximum value, the answer would have been 1 by 3. So the right option here is A. Now the function x square plus 2x plus c by x square plus 4x plus 3c assumes all real values only if a is equal to 1, b, c greater than or equal to 0, c lying between 0 to 1, the fourth option being mod c less than or equal to 1. Now let's look at this. Let's write this as y equal to x square plus 2x plus c by x square plus 4x plus 3c. Now what we want to say is the range of this function is entire R. That is, I have a function which maps x to y, and that y is this given by this rule. You have to say that every y real number, for every y real number, there is one particular x, which is also a real number satisfying this equation. Then it means that the range of this function is entire number line R. Okay, let's see here. Let's cross multiply. We write this as y minus 1 into x square plus 4y minus 2 into x. I'm cross multiplying and grouping the terms, and we have here c into 3y minus 1 equal to 0. Cross multiply, write it as a quadratic in x square. Now this equation must have a real root, must have a real root in x for each y. That's what you want. For every y real number you pick up from the codomain, you must be able to find an x satisfying this equation. That means this equation must have real root in x for each y. So first of all, for it to have a real root, what is it you should have? Discriminant should be greater than or equal to 0. That is, this discriminant, we'll write it in the form of 4y minus 2 the whole square minus 4 into y minus 1 into c times of 3y minus 1 should be greater than or equal to 0. I want this to happen for every y, for each y. Again, let's observe. Here, we will write this in the form of, you can take out a 2 common, 2 into 2y minus 1 the whole square, 2 square will give me 4. I will cancel out that 4, and I have here 4 into 2y minus 1 the whole square minus 4c into y minus 1 into 3y minus 1 greater than or equal to 0. Now, this 4, which is commonly coming up, we can cancel it out, and we have here 4y square minus 4y plus 1 minus c into 3y square minus 4y plus 1 to be greater than or equal to 0. So what does it give me? I want this to happen for every y real number, for each y real number. So we will rewrite in this in the form of 4 minus 3c as a quadratic expression in y, and plus 4y plus 4cy minus 4cy. So plus 4 into c minus 1 into y. Okay, minus c plus 1 there. So we will write it as 1 minus c greater than or equal to 0. I want this to happen for each y real number. Now this is a quadratic expression in y. Okay, so this is some function of y. I want this to be always non-negative. So the graph of that should be above, completely above the x-axis, either touching the x-axis or like this, either this or this. F of y graph, some z equal to f of y graph should be like this. Now it means that when is that going to happen? When is the graph concave upwards and above the x-axis? So coefficient of the y squared term should be positive. So 4 minus 3c should be positive. And discriminant should be less than or equal to 0 for all. Discriminant should be less than or equal to 0. Okay, for this to happen, to have a non-negative sign for all y. So this means that you will have 4 to be greater than 3c. That means c must be less than 4 by 3. That's one thing. And what else you have here? Okay, discriminant should be less than or equal to 0. So what is the discriminant? 16 into c minus 1 the whole square minus 16 into 4 minus 3c should be positive, and discriminant should be less than or equal to 0. So for 4 minus 3c to be positive, your c should be less than 4 by 3. Now let's look at the discriminant less than or equal to 0 condition. That is 16 into c minus 1 the whole square minus 4 into 4 minus 3c into 1 minus c should be less than or equal to 0. Now we will rewrite this as plus and c minus 1 here, so that I can take out c minus 1 common here, and there is a 4 common also, so we'll cancel out that 4. So we have 4 into c minus 1 into, we are left with a c minus 1 factor here, and we have plus 4 minus 3c. This whole thing should be less than or equal to 0. So we can actually ignore this, this c minus 1 here, and we have a 4 into c minus 1 here. Okay, so we have c minus 1 into, now what does this become? 4c minus 3c, that makes it c there, and then minus 4 plus 4, that's just simply c there, less than or equal to 0. So c into c minus 1 less than or equal to 0, it means that c should lie between 0 to 1. Okay, c should lie between 0 to 1. But then you also have said c should be less than 4 by 3. So c should be less than 4 by 3. What is it? Common region will be c should lie between 0 to 1 there. So the right option is answer C. Let's move on to the next question here. If A, B, C are distinct positive real numbers and a square plus b square plus c square is equal to 1, then AB plus BC plus CA is, first option less than 1, second option equal to 1, greater than 1, and any real number. Let's see how to go about this problem. Now what is the relation, what is an expression combining these two expressions, a square plus b square plus c square equal to 1 and ab plus bc plus ca? Now we know that a square plus b square plus c square minus ab minus bc minus ca is always non-negative. This is known, we know. We'll use this. How do we know this? It is in the form of half of a minus b the whole square plus b minus c the whole square plus c minus a the whole square. The sum of three non-negative real numbers. So non-negative. So it comes from here, since this is what we know. Now using this inequality, it's very clear now. A square plus b square plus c square is given to be 1. So that's 1. Therefore 1 minus ab plus bc plus ca should be greater than or equal to 0. So ab plus bc plus ca must be less than or equal to 1. Transposing the term that side, AB plus BC plus CA is less than or equal to 1. So what is the right option? Option is A there. Answer is A. Let's move on to the next question. In a triangle PQR, angle R is pi by 2. Triangle PQR, angle R is pi by 2. If tan P by 2 and tan Q by 2 are the roots of the equation ax square plus bx plus c equal to 0, with a not equal to 0, what should be the relation between ABC? A equal to b plus c, c equal to a plus b, b equal to c, and b is equal to a plus c. Let's see how to go about this. Now the triangle PQR. We have a triangle PQR, and it says the angle R, let's say PQR, angle R is 90. This is 90. So now it means that angle P plus angle Q will also be 90. So angle P by 2 plus angle P by Q by 2 will be pi by 2 by 2. So now he says tan of P by 2 and tan of Q by 2 are roots of the quadratic equation ax square plus bx plus c equal to 0. Now sum of the roots, tan P by 2 plus tan Q by 2 is equal to minus b by a. What about the product of the roots? Sum of the roots is this. Product, tan P by 2 into tan Q by 2, that is equal to c by a. Now can we have a relation between this coefficients? Use the relation here. What do you know? We just now have found that P by 2 plus Q by 2 is equal to pi by 4. We use the formula tan of A plus B formula. So tan, apply tan both sides. We get tan of P by 2 plus Q by 2 is equal to 1. Tan pi by 4 is 1. But what is tan of P by 2 plus Q by 2? Tan P by 2 plus tan Q by 2 by 1 minus tan P by 2 tan Q by 2. That is equal to 1. So from here it's very clear, tan P by 2 plus tan Q by 2 is minus b by a, and that should be equal to cross multiply, that's equal to 1 minus tan P by 2 into tan Q by 2. What is tan P by 2 into tan Q by 2? So 1 minus c by a. So from here, just transpose it this side. It's clear then that we have minus c minus b by a is equal to 1, or c is equal to a plus b. C is equal to a plus b. So the answer is clearly B. Option B is the right answer there. So let's move to the next question. If the equation a n x power n plus a n minus 1 into x power n minus 1, so on, a1x equal to 0, a1 not equal to 0, and n is greater than or equal to 2 has a positive root alpha, then the equation n into a n times x power n minus 1 plus n minus 1 into a n minus 1 into x power n minus 2, so on, up to a1 equals to 0 has a positive root which is greater than alpha, smaller than alpha, greater than or equal to alpha, and equal to alpha. These are the four options. Now let's have a close look at the first equation. What is the first equation? Let me write that as f of x equal to a n into x power n plus a n minus 1 into x power n minus 1, so on and so forth, up to a1 times x. So the least degree term in that is x there. Stopping with that. Now very clearly he says, very clearly from here, f of 0 is 0 because we have an x factor in every expression. So f of 0 is 0. So 0 is the root of f of x equal to 0. And he says it has a positive root. Alpha positive root is also a root. Alpha is a root. So let's visualize this graphically. He says 0 is a root and alpha is a root. That's a polynomial equation. The graph could have been either like this, or this is 0 and this is alpha. Or the graph could have been between 0 and alpha going down like this. In either way, you observe that the graph of this polynomial function, which is continuous and which is smooth, differentiable everywhere, you observe that it will take a turn in between 0 and alpha. So where it takes a turn, the tangent will become parallel to the x-axis. That means slope of the tangent will be 0, which means the derivative of the function will have to vanish at some point c between 0 and alpha. Now you observe that the second polynomial equation is given to be the derivative. What is f dash of x? N into an times x power n minus 1 plus n minus 1 into an minus 1 into x power n minus 2, so on and so forth, a1. That is what is the second polynomial that is given to us. So f dash of x equal to 0 clearly has f dash of x equal to 0 is happening at c. F dash of c is 0. So that is c, that c is lying between 0 and alpha. So what is it? C is a positive root for f dash of x equal to 0, and that is smaller than alpha. So the second equation has a positive root which is less than alpha. So what is the right option? The right option is answer B.